Answers positive till there's different signs. It's a big one. Ready? Positive and positive. Here's the biggie. Here's the biggie. Till there's different signs. Same sign, positive, different sign, negative. All right, ready? Same sign, positive. Same sign, positive. Different sign, negative. Ready? Here it is again. Same rules apply. Positive and positive, negative and negative. Answers positive till there's different sides. Same sign, positive, different sign. One more time so we can get it. Join me here, right? Same rules apply. Positive and positive, negative. Ready? Here's the big one. Answers positive till there's different signs. Same sign, positive, different sign, negative. That's the big key. That's the big key. Give us a little bit of DJ MC Santy there. Everybody, he's MC Santy. That's where it's at. I don't know. It's the connection between my computer and this. It's a little frustrating, but it's just how it goes. All right. So multiplying and dividing integer notes. So we take a look. What do we got here? So what did we learn? What did we learn from good old MC Santy? What did we learn? What's the answer? The answer's positive. What did he say? Till there's what? Different sides. So if it's the same sign, it's positive. Different sign, negative. So we've got a little song for us. So you guys already know. How many of you guys already wrote down the notes for this? Who already filled in the blanks? Good. Those of you who are paying attention, nice job filling in the blanks. We can get the multiplying integers one in there now. We get the multiplying integers. Hey, buddy, there's one literally right behind you. There's also some right in front of you. So next time, just get those. All right? You don't need to come up in that time. Especially if I'm filming. You want to be on the video?
Yeah.
Put your mug on the video. You don't have to. See, that's what I'm saying. You just got some behind you. So, multiplying integers, this is not something you need to write down. This is something you need to pay attention to while you glue. What do we figure out from the video? The product of two integers with the same sign is positive, because same sign, positive, different sign, negative. Join me, ready? Same sign, positive, different sign, negative. I'm going to keep going until everybody's joining me. Ready? Same sign, positive, different sign, negative. Now, some of you guys are like basses. You're like, you know, I've got a fairly decently high voice, but there's this thing for gentlemen called the falsetto. Okay, so the falsetto is the high part of your voice. All boys can do it, whether you have a low voice or a higher voice. All of you can go same sign, positive, different sign, negative. There's what's called your full voice and your falsetto. Listen carefully, ready? Did you guys hear that break? That's because I've really got a sore voice, sore throat, but all guys have breaks once you started that voice change thing. Your falsetto is that high part. Your full voice is the low part. So I expect even the boys to join me in it. Ready? Go. Same sign, positive, different sign, negative. Now, why do I distinguish between the rap and what I call the multiplication melody? Why do we distinguish? Why do I make sure that, I don't want you rapping this. I want you singing this one, but I want you rapping the ad rap. Why?
So you don't get mixed up.
So you don't get them mixed up. They are different rules. Right? Look at the rules. Look at the rules for this. So here, same sign add, different sign subtract. Wait a second. What? Now with this, it's a different rule. So it's a different technique to learn it. That's why we're all going to sing. That's why I want you all to sing. I don't care if you're a bad singer. I don't care if you're a good singer. Right now, I'm pretty bad. I got a really sore throat. But the idea is same sign, positive, different sign, negative. Notice the two different kinds of multiplication here. Multiplication with a little x, multiplication with the parentheses. Okay? Notice the difference. How do we know this is multiplication? It's a number directly in front of parentheses. What is this not?
Addition.
It's not addition. It's not subtraction. It does not say 6 minus 2. This says 6 times negative 2. When you have a number directly next to parentheses, that means multiplication. So what's our rule for this one? Same sign positive, different sign negative. So we have 6 examples we're going to do. Let's get these 6 examples in here. So you're going to write them down and solve them. I want you singing that song every time. So, what's the answer number 1? Why is it negative 6? Different sign negative. These are different sign negative. The key is just making sure you sing it low, right? The high is positive, the low is negative. Right? Same sign positive, different sign negative. What do we got next? Notice the different structure. See how I've written it in different ways? I want you to recognize the different ways of getting this. So what do we see here?
72. Oh, they're the same sign.
8 times 9 is 72, and now we have to assess the sign. What do we do about the sign for this one? Same sign positive. Sometimes I mute the part of the song that doesn't apply. Positive 72. Why is it not negative? But Mr. Strand, isn't it keep the sign on the bigger one so we can be exact? No, that's the add wrap. Add wrap, multiplication melody. Next one. Notice all the 3 different structures of multiplication. You see how they all look different, but they mean the same thing?
Huh?
All 3 of those problems look different, do they not?
No.
Okay. But they mean the same thing. Now, you may be able to do this one in your head. I want you to try it. Okay? No conversation yet. Come on. We don't need it. You should try this in your head. How can we structure this to do this one in our head? Well, what's 15 times 20? Better question, what's 15 times 2? What's 15 times 2?
30.
So 15 times 20 is 300. But this isn't times 20, it's times 18. So that's 2 15s less.
300.
Oh, is it?
What? 270.
270.
270.
Here's the deal. So I'm asking you to challenge yourself. Try to come up with a way that you can do this in your head. That's the way I did it. The way I did this was, I increased this by 2 to get it to 20. I increased it by 2 15s to get it to 300. So I need to decrease the answer by 2 15s to get it to 270. 300 minus 30 is 270. Now, if you can't process that yet, that's okay. I'm asking you to challenge yourself. I'm asking you to try. So remember, you can always use column multiplication. 8 times 5 is 40. 20. 5, 270. And now, of course, the sign of our answer. Same sign, positive, different sign. Exactly.
It's like music class.
Yes, it is.
I don't have any divided by total.
Told you there's going to be 6 examples like this. 6. So now,
Oh my.
of course, the answer to this one is going to be same sign, positive.
460.
Sign of our answer is going to be positive, right?
Yeah.
It's all the same sign. Same sign, positive.
No.
But let me ask you this.
Yes, it is.
2, you do this in your head. 2 plus 6 plus 9. 17, right? How did you do it, Rithik? How did you do that in your head? Did you add 2 plus 6 plus 9?
No, I just added 2 plus 6, then I got the answer, which was 8, then plus 9.
Exactly. Rithik just explained how to do 2 plus 6 plus 9. I asked him, did you add all 3 of those numbers together? And he said no. He had 2 plus 6, got the answer, then added 9. You can't add 3 numbers together, it's not possible. You can't do it. How many numbers can you add together?
2.
How many numbers can you multiply together?
2.
You can't multiply 3. You can multiply 2 numbers and then multiply it by another. But you cannot multiply 3 numbers together. So, same sign, positive. But then we have different sign, negative 64. So, does the rule for this stuff, the song, the multiplication melody, apply for 3 numbers? Does it apply for 4 numbers? Does it apply for 10 numbers? How many numbers does it apply for?
2.
2. Anytime you multiply, you use this multiplication melody. All right, here we go. Number 5. Told you there's going to be 6 examples. Yes.
So if you had like more than 3 numbers, would you like keep switching from positive to negative
Yes.
every single time?
Yep.
Okay, so,
We'll talk about that with exponents tomorrow.
Okay.
Jackson.
What if it was 4 numbers and the first 2 were in parentheses and then the next 2 were in parentheses?
Then you would do those first 2, then you do the next 2, and then you multiply the product. Yeah. That's a good question. 9. Huey. Stop talking. All right, who's got an idea of how we can do this? Give me a hand. Huey.
so I did 5 times -5. And I got -25
Why negative?
because
You'll
it's
best sing that song.
the different sign. And then,
Finish the song.
different sign. Same sign.
Get higher, man. Same sign, positive.
And then I got
No, I'm not asking. I already know it. I just need to know if you know it. Do you know it? The song? Let's hear it. I'm sorry. I called on you because I know you're a confident guy. There are other people in this class who I would not call on because they're not as confident as you. Show us your confidence.
Let me hear your singing voice.
You're next. So why is Huey correct on both these steps? Because
Same sign, positive, sign, negative.
that's what I'm talking about. Same sign, positive, different sign, negative. Exactly. So the idea behind this is making sure that you understand the multiplication melody. If you can sing the multiplication melody, then you are spot on. All right. Now, who did this problem a different way? Who did this problem a different way? Talal, talk us through what you did.
I did -5 times -4, which is going to equal 20.
Why?
Yeah, do song. Song.
Got it.
No, you didn't. Just do it in your voice.
different sign, negative.
There it is, because Huey's got the same sign, positive. Keep going. Keep going. Steps slow.
I want to sing. 5 times 20 is going to equal 100.
Good. So I got to ask you. So Huey's method and Talal's method, they're different, right? But they yielded the same result. Why?
Because, you're
Because
not
it's
doing,
the same 3 numbers.
There's a math reason as to why.
it's because they're in a certain, the numbers are in a certain pattern or
No.
way.
I like your idea. It's just not right.
Because no matter how you do it.
What's 3 times 4?
Oh.
What's 4 times 3? What property did we just demonstrate? The commutative property. So why were both of those methods acceptable? Commutative property. I'm going to share with you guys, to be honest with you, I prefer Talal's method because I like keeping signs the same. Same sign positive, because positive numbers to me are easier to work with. Right? Last one. Ashlyn.
5 times 0 equals 0.
Good, because there's a rule that we already talked about in elementary school called the 0 rule. Anything times 0
Actually, probably not.
is 0. Now, why am I having you write that down? Because it's not, that rule does not exist for division. It's specific to multiplication. This rule does not exist for division. We'll talk about that in a moment. Now, we need to move a lot faster. That took way too long to get through 6 problems. It's because people refuse to sing the song. Just sing the song. Dividing integers. So while you're gluing this next piece in, while you're gluing the next piece in, make sure you're listening. What's the rule for dividing? Quotient, product, sign, same rules apply. That's what the song said, right? Same rules apply. Positive and positive, negative and negative. Answers positive till there's what? Different signs. Sing with me. Same sign, positive. Different sign, negative. I'm going to do this until Elias sings. Ready? Same sign, positive. Different sign, negative. I'm going to do it until he actually sings instead of just mouths the words.
I sung it.
Good. I agree. I believe you. I
Let me
believe you.
hear you.
I believe.
So the rule is the same thing, right?
Yes.
Quotient, product, side, same rules apply. So, no difference. Let's get our 6 examples for division. Alright. What do we got? Ashley.
I got 6.
Because? Oh, so that sounded like a rap to me. Yes, same sign positive, different sign negative. All right, next one. Notice a different structure. It looks different, right? Notice, what is this? What is this thing called? This thing is called a fraction. What else is it?
A division.
Also a division problem. Fractions are division problems are fractions. Write either of them as any way. So what do we see here? Ryder, what do we got here, ma'am?
We have -7.
Good, why?
Come on. Sing it. Different sign.
I know everybody can. Ready? Let's everybody say something really high. Say, this is me talking high. Now, I didn't ask you to scream. There's a difference between screaming and talking high. We aren't screaming, right, John? And now I want you to say something really low. This is me talking low. Now I want you to go from, I'm talking high, now I'm talking low. See, that's what the song is. Same side positive, different side negative. Goes down. All right, let's go faster. I'm gonna have to edit so much out of this video now. Get over yourself, sing a song. Get over yourself, sing the song. Alright, what do we got again?
1.
Why?
Same sign positive, different sign negative.
Exactly, good. So these are the same sign. Another rule that we have is the division by 1 rule. It says if you divide a number by itself, then it's going to equal 1. Good. Moving on, let's see if we can do this one in your head.
Yes, let's go.
Process, let's think about it. There's multiple ways to think about this. I want you to try this one in your head. Okay? There's several ways to do it. I'll share my method and then somebody else can share theirs. First off, we know what the sign of our answer is going to be. Why? Max, why do we know the sign of our answer?
Because same sign positive, different sign.
That was awesome. Outstanding, man. Awesome. Because these are different sign negative. So how can we do this in our head? Well, let's think about it as just 3. So what number is 294 really close to that's really easy to divide? 300. So 300, okay? How many times does 3 go into 300? 100 times. But I had to move 294 up by 6. So I'm going to need to move my answer 100 down by a certain amount. How many times does 3 go into 6?
2.
So I need to move my answer, 100, down by 2 to get an answer of 98. Why? Because, well, if I round it up by 6, that's two threes, right? So my answer was 100. I'm off by 2 threes. So I need to bring it back down to 98. How many people rounded that down to 270 and said, well, 3 goes into 270 90 times. With 24 left over, that would be 8. So 90 and 8 gives us 88. That's another way to do that. Awesome. We have 2 last problems that are very, very important to us.
Oh God.
By the way, it's not 3. That's what I meant, sorry.
What does this say? This says, how many times does 8,453 go into 0?
8,453.
Nope. Goes into 0 times. Nope, it's 0. It's not undefined. It's 0. There's a big difference.
The other way around.
How much is in this box right now?
0.
There is nothing in this box. I'm going to split this nothing into 3 groups. Here, Rithik, take some nothing. Here you go. Take some nothing. Good. Now, I split this nothing into 3 groups. 1, 2, 3. How much is in your group, Rithik? How much are you holding? How much am I holding? So I split my nothing. I split my nothing into 3 groups, and all 3 of us had nothing in our answer. So if I split nothing into 8,453 groups, how much will be in each group? Nothing. That's why it's 0. That's why this one is much different.
Oh.
Number 6 is much different.
It's undivided.
If this is splitting things up into groups,
Oh, yeah.
was I able to split nothing into groups? I literally did it, right? Didn't I give you some nothing? Rithik, didn't I give you some nothing as well? I did that. I literally just did it. So was I able to do that? Was I able to split my nothing into multiple groups?
Yeah.
Literally, I did that, okay? So I was able to do that. Now, what about this? What am I able to do here? Shh, it's okay. Leave it alone. Here, am I able to split this into no groups? Hey, up here. Thank you. I have 8,453 things. I want to split it into nothing.
Then you have 8,453 things.
No, I have nothing.
But you didn't split it into anything.
Exactly.
So it'd be 8,453.
No, I split it into nothing.
0. Zero.
No, 0 is zero is something. I already showed you. I have nothing in here. That is something.
No.
If you had 8,453 things,
And I want to split it into 0 groups.
then it would be 8,453 things.
That's a group of 8,453.
One.
That means there would be one group.
Oh.
How are you splitting it? There's nothing.
How can I split it into no groups? How can I make 8,453 things no longer exist?
By
I
taking-
can't.
you can-
How about this? Let's do it this way. There are 30 of you. I want to split you into 2 groups. How many people will be in each group? There are 30 of you. I want to split you into 10 groups. How many people will be in each group? There are 30 of you. I want to split you into 1 group. How many people?
30.
There are 30 of you. I want to split you into 0 groups. How many people will be in each group?
None. Undefined.
0.
Well, there's a difference. There's a difference between 0 people in each group and not able to do it. Why can I split you into no groups? What's the least number of groups I can literally split you guys into?
1.
1. 30.
I said 1.
I cannot split you into no groups because that would mean you don't exist anymore. The smallest number of groups you can split something into is 1 group. Can I split this into no groups? No, I cannot. The math word for that is undefined. The way to remember that is if 0 is underneath, then it is undefined.
So I say the answer is
I like to think of this as moving boxes. Can I have boxes filled with nothing?
no.
Like if you're gonna move, let's say there's a moving company with a bunch of boxes. Can they be filled with nothing?
Yes.
But what if I have 8,453 things and I need to move them to the next house? Can I do that using no boxes, no trucks, no people?
No. Yes.
No, it's not possible. I can't move this many things to a new house without anything to help me move it.
No.
Your hands would be something.
How can I sleep out?
Can't do it. Okay.
You could get a big hand.
Don't forget your intro rules. We have our ad rep, we have our KCC, and now we have our multiplication melody. Okay? Same sign positive, different sign negative.